Welcome to This Is My Architecture. I'm Simon from AWS, great to have you here, and I'm joined today by Greg from Checkpoint Software Technologies. Now, Greg's going to tell us about what Checkpoint has done architecturally to make their product work in the cloud. You're probably familiar with existing models about security, you may even use the product, but it's kind of static in an existing environment, isn't it?
Absolutely. I mean, customers in general are moving to the cloud for the agile capabilities, and security has to follow the agile model as well.
Absolutely. So let's take a look at what we've got here. It's kind of a sandwich type model, but take us through how we do the scaling for these devices and what they are.
Absolutely. So we have to make our architectures align with your architectures in how we auto deploy, how we auto scale, and auto update policy. So what we have here is our reference architecture for our auto scale deployments, where on the external public subnets, we have a variety of gateway instances. And on the internal public subnets, this is where you have all your web farms and your application farms as well. And what we do here is we create an elastic load balancer sandwich around the firewalls. So packets coming from the internet and hit the ELB, and it now distributes the flows across the gateways that are deployed across multiple availability zones.
So these are active-active.
This is an active solution, exactly right.
So that's great with load balancing, if there's nodes that come in and out of service, scaling.
Exactly. Plus, if there is an issue in one of the availability zones, we've got a complete replication of the solution in the other availability zone.
Awesome.
So once the packets are forwarded onto the gateways, we send them back onto the load balancer. It's just another elastic load balancer. We refer to it as an internal just to kind of keep the nomenclature simple. And then traffic is distributed back to the instances inside. So this is the high-level architecture and packet flow just to kind of get traffic in and out of the VPC.
And so this is really a transparent layer, but using auto-scale groups along here. So talk us through firstly the instance types that typically you recommend to customers and also what the auto-scaling points are.
Yeah, great question. So M4 large, M4 2XL, M4 4XL, that's probably a good small, medium, and large that most of our customers work off of.
Yeah.
The nice thing is we're software, more cores equals more performance. From there, we choose to deploy an instance type as you configured based upon an attributes file that we put in our management station. And what happens is this management station acts as our security software controller. It enables us to automatically deploy the instances, automatically assign a security policy, and automatically establish trust between our management station and our security gateways.
So in your architecture, you really have an extendable, expandable capacity. So there's no kind of upper limit here, it's just more nodes jumping in, connecting into the sandwich.
That's exactly right. I mean, we like to think we have both vertical scalability, the ability to run in different instance types of different sizes, and we have the horizontal scalability using an elastic load balancer and an Amazon auto scaling group to help make that happen.
So this also means that I guess customers who are using Checkpoint software currently in their existing data center and they're migrating to AWS can kind of use the same tooling, they're familiar with the same interface, but they're able to have a limitless scale as they move workloads across into the cloud.
That's exactly right. It doesn't matter if this management runs in the cloud or runs on-premise, we're software. And fundamentally, we don't lose anything when we leave the physical data center and move it into the public cloud.
Fantastic. So really you're gaining availability, you're gaining scalability. It's that use of auto-scaling groups to really grow these on a capacity basis, which means you're also saving costs because you're reducing the number of EC2 nodes you need at any given time.
Absolutely, and it's not just scale up, but it's scale down as well. Traditionally, customers have over-provisioned their physical data centers to handle the peak load. Very high capital expenditures for that once-a-year time that they need to support it. Well, most customers now want to be able to support that higher level scale, but then scale back down and reduce the cost when they don't have those peak workloads.
For sure. Well, Greg, thank you so much for sharing what you've been doing with your architecture, and thanks everyone for joining us on This Is My Architecture.